is number 35. Okay. A wire 10 centimeters long is cut into two pieces. One piece is used to form a square and the other is used to form a circle. Yani we have a wire which is 10 makes both of these shapes. Okay, so they're asking the total area of the square and the circle is A. Part A show that A is this equation. Okay, we have given that the wire is 10 centimeters long. So this is what they told us here. So that means that this, and this plus all of this equals 10. So because we use this wire to make both of these shapes. So that means it's the perimeter of the square plus the circumference of the circle. So the perimeter of the square is what? It's side plus side plus side plus side, yani it's 4x. And the circumference of the circle is what? It's 2 pi r. Okay, so that means we have 10 equals to 2 pi r plus 4x. So, okay, now look in our equation here in our area. Everything in this equation is x. There's no r. That means we want to here, we're going to isolate r. We're going to keep it on its own. Okay, in this equation, we're going to keep it on its own so we could substitute it out later. You'll get what I mean when we solve it and get the answer in the end. So that means that our 2 pi r is equals to 10 minus 4x. So that means our r is just 10 minus 4x over 2 pi. Yani 10 divided by 2, you could just say it's 5 minus 2x over pi. Okay, this is our radius. Now they're saying that they want the area. So the area is just the total area, and it's this part here, plus this part here. They want us to add these two together and get its final equation. So the area of the square is what? It's going to be side times side, so it's x squared. And the area of the circle is pi r squared. Okay, so that means our area equals to x squared plus pi r squared. Okay, so that means it's x squared plus pi. Now instead of r, we'll give what we have for r. So this part here. So we'll say 5 minus 2x over pi squared. So I'll just square this top part alone and square the pi alone, so it's pi squared. Yeah? Okay. We'll simplify some more. This pi cancels out with this squared. Okay, so this part here we can remove. It cancels out with the pi. Now this top part here we're going to expand. So it's x squared plus, now it's 25 minus 20x plus 4x squared all over pi. Okay, this is after we expanded this top part here. Now let's see, here in our equation they showed that the whole thing is over pi. So this means that we need this x to be over pi. So we'll multiply by pi and divide by pi, common denominator. Okay, so now we could add everything up and get our final answer. It's going to be 25 minus 20x plus 4x squared and then plus pi x squared over pi. Okay, so now here we have two x squared terms, and we need to add them up. Here we have 4x squared and here we have pi x squared. So that means it's going to be 4 plus pi x squared. So I'll rewrite this. This here gives us 25 minus 20x plus 4 plus pi x squared. All of this over pi, and this is the equation they got here. So that means it's correct and we proved it. Okay. Now part B. For part B, they're saying that given x can change, find the value for which a has a stationary value. Okay. So I'll remove this so you have more space to work with. Part B, you should always be to solve. And if you couldn't do part A, just solve part B. Okay. they're saying find the value for which x which a has a stationary value. يعني we need to derive and equate to 0. Okay, because they want the stationary value يعني is the x y prime table. Remember this table where you do this and then you get increasing, decreasing, and whatever. Okay, so that's this table, they want that. So we'll take this equation. Okay, we'll take this and derive it. So our a prime is going to be, we could derive the top part separately and then put it all over pi. So yani this top part here, this first part here, is going to be 2 into 4 plus 4 plus pi into x. So here is pi. And then this second part here is minus 20. And then this part cancels out because it's constant, so then we put the rest over pi. Okay, so this is after we derive. Now after we derive, we'll equate this to 0. So 0 equals to 2 into 4 plus pi x minus 20 over pi. So we'll take this pi to the other side. So 0 times pi, it cancels out, so you can just remove this pi. Okay, then we'll take the 20 to the other side. So it's 20 equals to 2 into 4 plus pi times x. Then we could we'll divide by 2, so it becomes 10, and this 2 goes away. And then we could move this whole thing to the other side, so it's x equals to 10 over 4 plus pi. Okay, and this is our final answer. This is the value of x that they wanted. Okay, so that's part B. Number 36. A piece of wire of length 20 is bent to form the perimeter of a sector POQ of a circle. The radius of the circle is r and the angle POQ is theta radians as shown in the diagram below. Part A, express theta in terms of r and show that area a centimeter squared of the sector is given by this equation. Okay, let's see. The first part here is they want us to express theta in terms of r. Yani they want theta on one side and the rest of the equation on the other side. So let's see, what do we have? We have a wire of length 20. Okay, this is used to make this shape. Yani this plus this plus this all give you 20. So, okay, so let's see each side. We'll write it here as we're going. So this side here is r. So, and this side here is also r. So that means it's 2r plus this sector here. Now for this sector, you could see that in this question we're using radians. Okay, so the length of a sector in radians is going to be theta r. Okay, you can memorize this, it's a rule. So that means this part here is what? It's theta r. Okay, so it's 2r plus theta r. They want us to express theta in terms of r, and you'll keep theta on one side and everything else on the other. So it's 20 minus 2r equals to theta r. So we divide by r, so that means 20 minus 2r over r equals to theta. So this is the first part of that, and this is what they wanted. Now they want us to show that the area is this equation here. Okay, so we look at the area, this area here. What's the formula for it? Once again, we're using radians, so the formula for the sector in a circle is 1 over 2 theta r squared. Okay, that's the area. So we'll take it. The area is 1 over 2 theta r squared, and we have theta already, so we'll substitute. It's 1 over 2 times r squared and then times theta. Theta, what we have is 20 minus 2r over r. So I'll come here, 20 minus 2r over r. Okay, so this r squared cancels out with this r here. So right now we have 1 over 2 into 20 minus 2r. So, okay, so 1 over 2 times 20, this is 10, and then 1 over 2 times minus 2, just 1, so minus r. Hold on. Yeah, but I forgot, here we have also a radian, so that means we're just gonna add it back in, so it's times r and times r, so it becomes r squared. Okay, and we distributed this, and then we got here. Okay, and then we distributed also the radian, this r the radius, so we got to this as our final thing, and you could see that is the same as what they have here. So that means khalas, we proved it, and that's part A. Now part B, they're saying find the stationary value of A and determine its nature. Once again, this means that we need to derive and equate to 0. So we have our area is 10r minus r squared. So our area prime after deriving is going to be 10 minus 2r. Okay, take this, equate it to 0, so you get 2r equals to 10, so r is 5. Okay, but they're not asking for your radius, they're asking for A. Okay, so you take this 5 and put it back into our A. Okay, so we'll say 10 into 5 minus 5 squared. So it's 50 minus 25, so 25 is your answer. Okay, now the second part of this question, they're saying determine its nature. And they're asking, is it local minimum, is it local maximum, what's going on with it? Okay, so to find this, we're gonna do the table of variation. So it's x into a prime. We see here that it's 5. Okay, this gives us 0. Okay, instead of x here, you would write r for radius. Okay, we'll test a point here, you'll find that it's going up, it's positive, and you'll test a point here, it's going down, it's negative. Okay, so that means that this value, r is 5, is a maximum. So there you go, that means you determined its nature. So that's the answer to your question. It's maximum, and the value of A is 25. Number 37. The diagram below shows the dimensions in meters of a garden. The perimeter of the garden is 48. Part A, they're asking to find the expression for y in terms of x. And they want you to find y. Okay, so we know that all these sides added up is 48. Because that's what the perimeter is. Okay, so that's easy. So we'll just add everything up. So here, let's see, this part is what is 2x plus, we'll add all the x's first, plus x plus 3x. Okay, and then plus the y's. This part here is plus y, this part here is plus 2y, and for this part they didn't tell us its value, but we could see if this part is 2y and this one is y, so that means this part is also y, so plus y. Okay, so in the end, 2x plus x plus 3x, you get 6x plus y plus 2y plus y is 4y. Okay, so this, when you add them together, you get 48. Okay, they want us to express the y, so you keep the y on its own, so 4y equals to 48 minus 6x, and then we divide by 4, so y is equals to 48 divided by 4 is 12, and then 6 over 4 is 6 over 4x. Okay, 6 over 4 you could simplify, gives you 3 over 2. So that's the first part, that's your expression for part A. Now part B, they're saying given that the area of the garden is a meter squared, show that the area is 48x squared minus 6x squared. Okay, so this shape here, we could split this into two shapes to find its area. We could split it into this, for example, so it's this area 1, and then it's this area 2. So okay, so it's area 1 plus area 2. Area 1 is what? Area 1 is this part here, which is 2x. 2x times the height. Yeah, so times y. So it's just 2xy. Now for area 2, it's what? You look at the base times the height. So the base is x, so plus x times the height is 2y. Okay, that's area 1 and this is area 2. So now we have, this is our total area, is 2xy plus 2xy. Okay, this part is 2xy, and this part is also 2xy. So we add these together, yani it's 4xy. So we'll say here that our total area is 4xy. Okay, again, so I split this thing, I split it into two shapes. Okay, we split it into this area and this area. Okay, this area here, base times height, so 2x times y, plus this area, x times 2y. Okay, and then we take those areas, we add them up to find the total area, because that's what they want. Area of the garden, so total area. So now we have this equation. They want us to show that the area is 48 minus 6x squared. Okay, to do this, we're going to take our y, so this part here, and we're going to substitute it into our equation we had in the beginning. Okay, so I'll take this, I'll write it here. We have our area is 4xy. So we'll substitute the y, so it's 4x into, we got 12 minus 3 over 2x. Yeah, so now we can start simplifying more. 4x, we'll distribute the 4x, so it's 12 times 4 is 48x, minus now 3 over 2 times 4 is 6, so minus 6x squared. Okay, so you check, this is the same equation here, the same as this, so khalas, that means we got it correct. Okay, now part C, they're saying given that x can change, find the maximum area of the garden, showing that this is a maximum value rather than a minimum value. Okay, when they're asking to find the maximum or minimum, we need to, once again, we need to derive and then we equate to 0. Okay, so we'll take the equation we have, which is 48x minus 6x squared, and then we derive it. Okay, so a prime is 48 minus 12x. This is our a prime. We equate it to 0, so you get 12x equals to 48. So that means our x is equal to 4. Okay, so now we have our x. We need to show that this maximum is not a minimum. Okay, we need to prove it. Yani we'll do our table of variation. I'll do it here, we have space. I'll do this x and then our y prime, or our area, you could call it whatever. So here we got it 4. This gives us 0. So we'll test a point here, we'll find that it gives you positive. We'll test a point here that it gives you negative. I mean, it's going up, then it's going down, so this point is a maximum. When you draw this table, this shows them that you're proving it, so that you need to draw it in the exam. You need to show them that we got x is 4, I need to show them that we drew the table. Okay, number 38. The diagram below shows a metal plate consisting of a rectangle with sides x and y and the quarter circle of radius x. The perimeter of the plate is 20. Okay, part A, they want us to express y in terms of x. So first thing, we know that the perimeter is 20. Yani this plus this plus this whole thing plus this all together gives you 20. So our 20 is equals to, let's see, this side here, we'll do it first, so it's x plus this side, this whole thing, it's x plus y, plus x plus y, and then we have this top part here, it's plus y, and then we have this sector here. Okay, first I'll simplify this part, so this is just 2x plus 2y, so we have more space, so it's 2x plus 2y, and then plus the sector that we have here is this part. Normally the circumference for a full circle, if you had a full circle, it would be what? It would be 2 pi r. But here this is a quarter circle, yani it's quarter of that. So 2 pi r times 1 over 4. So that means it's just 1 over 2 pi r. Okay, that's the length of the sector here. Okay, so plus 1 over 2 pi r. This is our equation that we have now. They want us to express y in terms of x, and you keep y alone. So I'll keep the y alone is equals to 20 minus 2x minus 1 over 2 pi r. Okay, and then we divide everything by 2. So our y is equals to 10 minus x minus 1 over 4 pi r. This is our equation, this is part A. And one thing, instead of saying radius, they showed that the radius is x. So you could just replace this r here with x. Okay, it's the same thing, yani. They didn't say radius r, they said radius x. Okay. Part B, they're saying show that the area of the plate is given by this equation. Okay, yani they want the whole area, the whole equation. So that we'll split this into two to make it easier. So this area, okay, this part here, plus this part here, I'll do it in a different color, plus this part here. Okay, so this first part here, this is just going to be x times y. صح. The area of this is base times height, so x times y. Now the area for this circle here, normally when you have a full circle, the area is pi r squared. Here this is a quarter circle, so times 1 over 4, so it's just 1 over 4 pi r squared. Okay, now they want the total area, so our area is just the adding both of these, so xy plus 1 over 4 pi r squared. So because this is the total area, this is what they want. Now we'll take this and we'll substitute in our equation with y. So we have y is this 10 minus x minus 1 over 4 pi x. So we'll take that and we'll substitute it into here. So it's 10 minus x minus 1 over 4 pi x. Okay, this plus 1 over 4 pi r squared. We substituted the y, that's all we did. Okay, so now here I'm gonna distribute the x, so it's 10x minus x squared minus 1 over 4 pi x squared, and then plus 1 over 4, sorry, once again, this isn't r, this is x, okay, plus 1 over 4 pi x squared. So this part here cancels out with this part, okay, 1 over 4, and this part cancels out. So we're left with 10x minus x squared. Okay, we come back, we see that this is the area they have, so we proved it correct. Now part C, find the value of x at which a is stationary. Okay, so this is our area. Okay, I'll go back to that. This is our area. When they want talking about stationary, maximum, minimum, we're gonna derive. So a prime is 10 minus 2x. Take this, equate it to 0. So 2x is 10. So x is 5. Okay, this is part C. They're asking for the value of x, which is 5. Okay, now part D, they're saying determine whether it's a maximum or a minimum. So we make the table. So x and then a prime. Yeah, so it's 5. This is 0. We'll test a point here. Yeah, you test a point here, you get positive. You test a point here, you get negative. So it's going up, then down. So that means that this is a maximum. Okay, so that's part D. Number 39, this is the last question. The diagram below shows a glass window consisting of a rectangle of height h and width 2r and a semicircle of radius r. The perimeter of the window is 12 meters. Part A, express the height in terms of r. Okay, we have that everything, all of this together is 12. So, okay, so we'll split it everything into pieces so we could do it together. This part here is h, this part's h, this part here is 2r. Okay, so when you add all of these up, it's h plus 2r plus h, now plus this circumference here, this semicircle. So normally in a full circle you would have it as what? As 2 pi r. But here it's a semicircle, so 1 over 2 times 2 pi r. Because this is a half circle, not a full one. So that means it's just pi r. 1 over 2 times 2 is pi r. So that means this part is pi r. So here we're going to add pi r. Okay, this is our perimeter, and they said our perimeter is 12. So all this equals to 12. they want us to express our height. So that means we need to keep all the h's on one side and everything else on the other. So here h plus h is 2h, and then we'll move everything to the other side. So it's 12 minus 2r minus pi r. Okay, divide everything by 2, so our height is 6 minus r minus pi r over 2. Or actually, here in this case, I'm gonna go ahead and keep it as one thing, minus 2r minus pi r, all of this over 2. Okay, so this is our height. Part B, they're show that the area of the window is given by A is 12r minus 2r squared minus half pi r squared. So that means this area plus this area. Okay, this area at the bottom here is base times height, so it's just 2r times height. Okay, now this top here, normally in a full circle you'd have pi r squared, but here it's a semicircle, so we'll do 1 over 2 pi r squared. Okay, we'll add both of these areas together like this. So area is 2rh plus 1 over 2 pi r squared. Okay, so we'll substitute our height. So it's 2r times our height, we got 12 minus 2r minus pi r over 2, and then plus 1 over 2 pi r squared. Okay, so this 2 cancels out this 2, so we have r, we'll distribute it in, so it's 12r minus 2r squared minus pi r squared plus 1 over 2 pi r squared. Okay, now we'll do this part here. So in the end here we get 12r minus 2r squared, and then minus 1 plus 1 over 2, so it's minus 1 over 2 pi r squared. Okay, these pi's don't cancel because they count as like a part of the r. Okay, so you don't change anything of the pi's, you just take the coefficients, so minus 1 plus 1 over 2, so you get minus 1 over 2. The pi's stay as a part of the r. Okay, I'm just explaining the simplification of this part. So this is our final area, is 12r minus 2. I'm not going to write it again. Yeah, this is our area. Okay, this thing. So let's see, is that the same thing they had here? Yes, it's the same, so that means we proved it correct. Now, given that r can vary, find the value of r for which a has a stationary value. And they want us to derive and equate to 0. Okay, so here our a prime is what is 12 minus 4r, and then it's just minus pi r. Okay, you could equate this to 0. After you shift solve, you could get, or actually no, we're not going to shift solve because you need to get it as a value. Okay, so we'll move these two to the other side, so it's 12 equals to 4r plus pi r. We'll factor out the r, so it's 12 equals to 4 plus pi all into r. Yeah, we factored out the r, we took it out, and then we'll take this to the other side, so the r is 12 over 4 plus pi. Okay, so that's part C. They said find the value of r, and that's it. And part D, whether maximum or minimum, so we'll do the table. So r and then the area. So the table, it's 12 over 4 plus pi. Okay, we'll test a point here, you get a positive number. Test a point here, you get a negative, going up and down, so that means it's a maximum.